Good evening, everyone, and welcome along to this Engineering New Zealand Mechanical Engineering Group presentation, coming to you live from Jeff's place to wherever you are. So first, just a wee plug for the Mechanical Group. So the Engineering New Zealand Mechanical Group is open to anyone with an interest in mechanical engineering. You don't have to be a member of Engineering New Zealand, and in return, you'll get approximately a technical presentation or site visit a month, which are all very interesting, and also a chance to mix and mingle and network with your fellow mechanical engineers. Now, on to our man of the moment here. So Pastoral Robotics was created to address the problem of nitrate leaching by dairy stock. And along the last few years, as it's gone from glimmer in Jeff's eye to an iterative series of working prototypes to a real product, it's picked up a few awards. A couple of years ago, it won the Engineering New Zealand Auckland branch Arthur Mead Award, and most recently also the IMECE Environment and Sustainability Prize, which Jeff has recently been to London to collect. So welcome to you, Jeff. Thank you for presenting tonight, and yes, I'll take it away, and I'll take questions from the chat panel here. So if you have questions, please type them into the chat box, and then we'll do questions and answers after the presentation. Okay, thanks, Jeff.
Oh, thanks, Simon. You can hear me clearly there? Right, so the environment is something that we were all hearing an awful lot about prior to COVID-19, and this young lady certainly filled the television screens a lot in the evenings. Interestingly, there's the other side of the coin, which in many ways was more serious. Nationwide chaos in Holland and in Europe and in Germany and Ireland, when the farmers protesting against the environmental changes being forced upon them decided to drive on the autobahns, quite legally of course, at 40 kilometres an hour in their tractors, and brought the countries to complete standstill. Major protests and a lot of tensions running. Similarly in France, actions taken by a group we've all heard of called the Yellow Shirts were literally about protests against things that were being done that were, in their opinion, reducing standard of living due to climate change and the environment. The young engineer there from works for us at Pastoral Robotics, and there he is, in fact, the friendly police officer. So in New Zealand, one of the biggest issues that we hear about a lot is nitrate leaching, which is a form of loss of nitrogen off farm. And nitrate leaching affects water quality. Here we have a photo that I took almost exactly a year ago after a friend's wedding of the Hooker Falls. You can see the water quality is very good. In fact, Lake Taupo is one of the cleanest lakes of its size in the world, and you can drink that water. A little bit further downstream, however, exactly 100 kilometres downstream at the Arapuni Dam, same day, you certainly wouldn't drink it. You might swim in it, but the water quality has come down a long way. And there are a few towns and so forth along the route, so it's not only dairy farming, but an awful lot of that water quality is a dairy farming issue. And there's a problem out there that needs to be solved, and we believe can be solved in a way that's really acceptable to the farming community as well as everybody else. Nitrate leaching, it's a global problem. Something like 60% of Europe's lakes, rivers and estuaries don't actually meet the European nitrate limit, which is about the same as ours. We're nowhere near as bad as that, but it's certainly something we all aspire to solve. And it shouldn't be forgotten that there are about 1 billion cattle in the world, and most of them spend most of their time on pasture. It really is a global problem. So in New Zealand, nitrate leaching is a seriously underestimated problem. The group from Cap Ag Limited did a study that was published last year on the Upper Manawatu catchment, and what they found was that 65% of farms in that catchment will go out of business if they are forced to meet the current nitrate can't remember, but there was a court action all around what they would and wouldn't have to meet. But if you expand that out New Zealand-wide, that's 2,000 to 3,000 dairy farms. Now, typically those farms are the farms on the most sensitive catchments because they're the farms that were latest in being converted to dairy. They're highly debt loaded compared to most farms, and they're the ones at most risk. Now, good dairy land is worth 40,000 a hectare. The average farm is about 150 hectares. Non-dairy land, probably half that. So the asset loss that these farms are looking at is about 3 million per farm. Most of them will be worth considerably less than their bank debt. Now, the banks are owed 42 billion by dairy farmers at the moment. That puts really our banking system at risk, and it certainly puts some of our very large companies at risk as well. And I compare them in this little slide here to ostriches, but I think the important point is they're a bit different to ostriches because ostriches don't actually put their heads in the sand. So what is the source of this major problem that's facing our industry? And of course it's urine and urine patches from dairy cows. And one thing I promise you is that you'll never look at a paddock the same again after listening to me talk about this issue. So what we have here is a typical dairy pasture. You can see the cows in the background, and you can see the large lumps of vigorously growing grass interspersed amongst the general pasture. When you look at it at eye level, there seem to be more lumps in general pasture, but if you look above, the lumps are about 10% of the paddock. Those lumps of grass are there because urine is full of nitrogen, which grass and in fact all plants need to grow. And the high amount of nitrogen in the urine makes the grass grow very vigorously. Unfortunately, there's way more nitrogen there than just normal grass growth can use. So should it rain, there'll be a lot of excess nitrogen in the nitrate form that is available to leach, and in other conditions it can convert to gases such as nitrous oxide and ammonia, both of which are pretty bad for the environment. So getting used to the system. So as I was saying, that nitrogen can be lost to the atmosphere, and it can also be lost to our aquifers, rivers and lakes. So what's happening here, the cow urinates a whole lot of urea, that's the form the nitrogen is in the urine. That then relatively rapidly converts to ammonium. Now the ammonium ions bind to the soil, and then reactions going on in the soil convert that to nitrate. Further reactions that then go on convert that to nitrogen, nitrous oxide, ammonia. Some of it goes to grass growth. And that's the good stuff. That's the stuff that the farmers want, of course. And then, of course, a lot is lost with nitrate. Now, one of the things about these reactions is they're largely bacterial. Right? And we can actually bias those microbial reactions. For example, we can slow down the transformation of ammonium to nitrate. What that means is that available water-soluble nitrate is available over a much longer period of time and lower concentration. The grass still uses the same amount, but it grows for twice as long, so you get a lot more grass growth. And that leaves a lot less for all the undesirable outcomes. Similarly, the conversion into nitrous oxide, we can play with that, and we can play with other reactions that are going on. So we can even encourage microbial growth in the soil. Microbes have proteins in them, so they need that nitrogen. Then later on they die, they release the nitrogen, and again that keeps grass growing. And finally, we can actually put in growth promotants in the treatment, and that increases the amount of grass growth. So the big goal here, less loss to the environment in nasty ways and a lot more making the farmer wealthier, which if you think about it is ideal, because if we're growing more grass, the farmers are going to want to implement this technology. It won't only be stick driven, there's actually a big carrot out there, and we all know that a carrot is much better than a stick. So what have we done? Well, first of all, we had to detect the urine patches, and we developed this machine here that you see called spiking. And along the bottom, there's a row of electrodes which are spiked wheels. They're spiked so that they get through the grass matter and make contact with the soil. And those wheels are actually electrodes, so they don't damage the soil, they just make contact with it. But when they do detect a urine patch, which they do from a conductivity-based method, there are a number of spray nozzles directly behind the electrodes which spray immediately onto that urine patch. And this is quite cool because it opens up a whole new possibility. Prior to spiky, all you could do was treat that entire paddock as being the same. But you'll remember from that earlier slide, which go back to, when you looked at that paddock, clearly it's not the same. So we can start to treat the urine patch quite differently to how we treat the bulk of the paddock. And you'd appreciate that if the urine patch has got too much nitrogen and we hold all that nitrogen up, then if we do that to an area of grass that has the right amount of nitrogen, we're going to severely restrict the growth. So by being able to actually make more nitrogen grow where we want the nitrogen to grow, we can have a really big impact on the outcomes we want, and we can completely bias what we're doing to the soil to be optimum. So this is the big breakthrough behind the machine, if you like. Now this machine is used in what's known in farming circles as a follow the cows application. So for optimum grass growth, the cows will usually move paddocks at least every day, and follow the cows means you come in straight after or the next day and treat that paddock with spiky or with whatever treatment the farmer's doing. So it's an opportunity to really make a difference in immediately that urine has been applied. So spiky, because it's going over the paddock in this follow the cows fashion, is also an opportunity to put the fertilizer on at the same time. So some farmers already do follow the cows fertilizer application, but it's a big hassle. So most will get a contractor in, and they'll come in every so often. So some paddocks will be treated immediately before the grass is grown, and others will be treated immediately after they've been grazed, and there'll be a whole lot in between. But if we can always treat the paddock straight after grazing, then things like the nitrogen application are applied right at the moment the grass really needs it. The grass grows, absorbs it, has quite a high amount of nitrogen in its leaf matter, and as it grows it uses that up. So it's at its minimum when the cows come in to eat it again. So when that grass is now eaten, the nitrogen that's in it, some of it goes to milk. The rest goes out in urine, but because we've reduced the amount that was in the grass, there's less in the urine. And so there's already a reduced urine patch problem, then we treat the urine patches. So the effects are quite cumulative, and the outcomes are very, very positive, both for the farmer and for the environment. So the next question is, well, what is going on and how do we measure it? And now I'm a mechanical engineer or mechatronic engineer. I know a bit about electronics and mechanics, but when I first got into this, I knew very little about actually doing things agriculturally. And I must admit, as an engineer, you build something, you break it, it wasn't strong enough, you analyze why, you build another one. Unfortunately, in agriculture, you set up an experiment, you're lucky you ask a few questions, you then wait an entire season, and you get an answer and go back to the drawing board. It's an extraordinarily frustrating process, but the way we measure nitrate leaching is that we create these things called lysimeters, which are large drums, typically 500 millimeters in diameter, typically 600 mil deep. We fill them with undisturbed soil, and that in itself is quite a challenge. You need to sort of brush your way down as you slide these drums into the soil, a bit like an archaeologist. Then you seal the bottom off, capture all the leachate, and take that out to some container so that you can analyze it. Now we're talking about a natural system, so you need to be able to statistically support your measurements. So you can't just do this with one lysimeter, you actually need 5 or 10 per measurement. So you need an awful lot of these, and then of course you've got to have your untreated control, you've got to have your urine control, and then you can start to ask questions. So in all, if you really want to get numbers that matter, you actually need 40 or so in a set to do an experiment. And we've built quite a few of these facilities all around New Zealand now. We have, this isn't quite the latest version of the slideshow, but we have 40 in Central North Island soils. We have another 40 in Canterbury. We've got another 25 leased in Canterbury. We've got another 20 leased in Manawatu. We've just started building a set of 60 in Rotorua, and we're planning, and we would have leased this year, but COVID-19 came along and we weren't able to be prepared in time, another 70 odd in Waikato and Manawatu. So it's a huge investment. We've got hundreds of these things around the country, and from that we're able to measure the impacts of various treatments and what they will have in the real world when we get out on farm. And some of the results we're getting are phenomenal. They're really, really exciting. These aren't results we can guarantee to get right at the moment, but we're certainly getting up to 100% increase in herbage growth, up to 70% reductions in nitrous oxide, and up to 74% reductions in nitrate leaching. In fact, the best single result we've ever got was 100% reduction in nitrate leaching, which is phenomenal. Over the full season, we're still a bit lacking in data that we're happy with, but we've certainly been seeing 30% reductions in nitrate leaching, with the potential and hints when we know more and really optimize what we're doing that we can get well above that. And that's just on the spiky treatment without the addition of the third system that I explained earlier. So it's got a huge amount of potential, and we're already getting really good results. Results that mean, from a farmer's point of view, they can implement spiky at a positive benefit to their cash flow, or at least a break even, and solve all those nasty environmental problems that are really putting their businesses at risk. That's pretty exciting stuff. The next question is, well, how good are we? And that's always a very good question to ask. Well, it's better not to take my word for it, but to have independent research. And the Global Partnership on Livestock Emissions Research, which New Zealand government subscribes to, undertook a project where we supplied a spiky, a little bit modified for scientific purposes, where we could actually look at all the raw data and tell them exactly where the urine patches were. And it was used in the Manawatu, in the Waikato, a place called just out of Sydney, and in Johnston Castle, in Ireland by Chargish, the equivalent of ag research, if you like. At each site, there was a wet side and a dry side. So it would be worth commenting that the Australian wet side was somewhat drier than the Irish dry side. On each side, 18 urine patches of 1, 2, and 3 litres in volume were poured, randomly mixed amongst them. So that's 36 urine patches on each side. And what you see in this slide here is the red is what spiky detected, and the green is what actually grew. So you always get the roots feed in, so the actual growth patch is always significantly bigger than the actual urine patch. And we tested at 2 hours, 4 hours, 24 and 48 hours. There's a bit of GPS registration error there because we checked out on the GPS, but you'll notice that we actually accurately detected every urine patch in all of those tests. So that's nearly 600 tests with 100% detection rate, no false positives and no false negatives. So we're pretty proud of what our technology can do. And I have to say, it's taken us a long time to get to this point. We've been going for 8 years now, but it's a pretty cool result. So what we have really is a game-changing technology. We've created a new era of applied agronomic science, one where you don't just treat a paddock as a paddock, you actually treat individual variation in that paddock as something you can treat down to a level where we're pixelating a paddock at 200 by 60 millimeters. So that's an awful lot of data off one bit of the farm. It's a new form of precision farming, and there really is a lack of science to support what we can do, and that's our goal, is to really optimize what can be done. I'd have to say it's a hugely I'll just go back a bit. It's a it's got a huge amount of potential, but as you can already see, we've had major mechanical and electronic development. We've got chemical development. We've got animals involved. Really, if you want to start a business, please just pick on one thing. Whatever you do, don't combine all this science and engineering and different parts of engineering and science together. It really is a long and hard road. And if you really want to make it happen, it takes a bit of sacrifice. You actually have to give up some things that are very close to your heart, well, that's what it really takes, I guess. But it's been 8 years. We've now got some really, really good data, and we're looking for the next level of getting proof out there that is accepted by the bureaucracy, so that the farmer actually gets credit. And you might want to sit back and think, well, if you were Jeff Bates 8 years ago, or if you came across him and Bert, his business partner, what would you say? Well, you'd say they're nuts, because start any normal business and you've probably got a 30% chance of success. And that's a pretty common statistic, I think, pretty close. Similarly, if there's a bit of science risk in there, there's probably a 30% chance that the science risk is going to be overcome. And similarly, with the engineering, new product development, a lot of the electronics, there's probably a 30% chance of success there. Finally, in this sort of business, well, there's a lot of bureaucracy to overcome for what we're doing to be accepted. And if it's not accepted, why would anyone invest in it? So that adds another 30% chance. Of course, if you're doing all that, you need an awful lot of finance and capital, and it's pretty damn hard to raise money in a small country. So that adds another 30% chance. So 8 years ago, I figure we had about a 0.24% chance of success. Frankly, you don't do this sort of business because you're in it to make a fortune, although as you get further down, there may be options. You really have to have a much higher cause. For me, anyway, it's very much about actually creating something that really does make a difference to the environment that I love so much. And I think that's the same for the rest of the team. This is no one-man event. It's a bit of a cliche, but you just cannot get your head over all the various things that are involved in such a development. So you need a team, you need a lot of specialists, you need a lot of people who are really driven. And that's something we've got. So it's really, really neat that we're recognised both by Mechanical or Engineering New Zealand a couple of years ago and then by the Institute of Mechanical Engineers in London. It was a real buzz. It's been quite a battle to get there, and to actually have your peers do a bit of a review of what you're doing and come to the conclusion that it's really good stuff is awesome. No other way to describe it. So what impact could this technology have if we get over the next hurdle or we commercialise it successfully? Well, a 15% increase in grass growth in the shoulder seasons. Commercially, for the farmer, that's where they have to do the most work. And environmentally, that's where they do things like winter cropping and external feed. So that's where you can have the biggest impact, by displacing that winter cropping and external feed. Secondly, we believe we can reduce nitrate levels to the point where it really minimises the problem and gets rid of it from being a health issue, if you like, in New Zealand, Europe, and in much of the rest of the world. We also think from some work, we haven't done as much work, but we believe we can make a 5 to 10% reduction in the New Zealand greenhouse gas emissions, which is it's pretty significant. Finally, from a economic point of view, it takes the risk away from our banking system and from our dairy farming system, which is really important. COVID-19 has sort of hidden it a bit, but it's there, and the last thing New Zealand needs is another shock to its economy at the moment. And when you look at the potential of this technology to reduce greenhouse gas emissions, and you look at what pastoral robotics could grow to, then potentially the technology could reduce global greenhouse gas emissions by over twice New Zealand's total greenhouse gas emissions. Now that's quite an important thing to think about, because we are risking to spend billions to try and become a zero carbon economy. Whether that goal could ever even be achieved, and there would certainly be a lot of social hurt, if you remember those early slides, that would come with it. Perhaps it might be smarter to invest a few million and really get this company off the ground from a national point of view. Perhaps I'm dreaming, but that's the reality. Is if we want to think global and really have an impact, we only probably need a few hundred companies with the same sort of potential of pastoral robotics to really solve the greenhouse gas emission problem. By changing our standard of living, we're going to open a whole other can of worms. So that's pastoral robotics. It's certainly been my passion for a long time. I probably got through the talk a little bit quicker than I thought, but I hope you've appreciated where we're at, and I can see quite a few questions have come in. So I'm more than happy to answer them and talk about it further.
Well, thanks, Jeff. That was really interesting. It's great to see how far you've come with Spiky, and also very interesting to see some of your other your testing there as well. All right, so I'll just sort of kick off some questions here. So we've got What effect does the rain have on your urine patch detection?
So generally speaking, it improves our detection because it helps make contact with the ground. If you have a really big downpour, then no, it'll wash the urine away and there's just nothing we can do. But those types of downpours are very rare. For example, in Canterbury, under irrigation, where you get a fair dumping, but only for a short period, irrigation, you actually get a better signal, so the system works better, not worse. But in dry weather we can, well, in weather where the soil is moist, but we're not getting huge amounts of rain, we can detect out for several weeks. Not that that's much use, because what do you do later on anyway? It's already too late to treat. We only really need those first 48, 72 hours for detection.
Mm-hmm. Just had a sort of not so technical question there. Can you just come a bit further forward towards your camera?
Sorry.
There we go. Yep, probably might improve sound quality slightly too. Yep, thanks.
Oh, just the microphone on your headphones, Jeff. If you just want to bring them forward a little bit, if you can, where the microphone is. Yeah. It was just tucked in behind. It was just giving a little bit of feedback there. That might be much better. Thank you so much.
Hopefully you're able to hear the bulk of the presentation.
All right. So another question here for you, Jeff. Is the weight of the tractor unit moving across the paddock detrimental to the grass growth?
Not noticeably. Tractors have fairly large tyres. It's nowhere near as bad as the hoof of an animal in wet soil. And it's worth noting that the soils where you get the worst leaching aren't the clay soils that pug up really badly. They're more the soils that keep dry over the winter anyway. So, I mean, ideally we'd use a small robot, hence the name of the company, Pastoral Robotics. But we had to make a decision early on to focus on the unique part of our technology and get that working really well. So that's what we've done at this point in time.
Mm-hmm. That sort of leads into another question I had for you here. Was are there any plans for maybe a smaller version for uneven terrain?
Yes, there's one and just about finished in our workshop right as we speak. It's more targeted at smaller farms than uneven terrain. The spiker you see before you is extremely flexible. The wings go up and down, the back goes up and down. The spikes are on very flexible attachment system. So it will follow the terrain pretty well, and if it won't follow it, it's starting to become pretty marginal dairy country as well.
Right, and I was also wondering, could you maybe run us through the development process that led to the spiked wheel? Was that sort of the very first sort of iteration of that, or?
So yes, it's a bit of a long time ago, but I met this fellow called Bert Quinn, and he reckoned if we could detect the urine patch, he could treat it. And so I went away and sort of thought, well, how would you detect the urine patch? I tried visual ways, but the problem with visual is that, well, there's several problems with visual. Firstly, if you're relying on grass growth, you have to wait till the grass is grown, so we had to throw that out. Secondly, if you're relying on spectral responses, you have a lot of environmental noise to deal with. And then finally, we're on the paddock at what I like to call peak shit. Literally, the cows have just been over the paddock, so anything relying on lenses has a real difficulty in keeping it clean. So eventually, after proving that we could do it, we put that method aside as being impractical. And we tried a number of other bits and pieces, and then finally thought, well, let's just see what can be measured with conductivity, and literally attached a few nails to the end of a multimeter and put it on the end of a broom and went round with some urine patches in my garden. The grass grew really well there for a while too. And funnily enough, I was able to detect it. Sort of that led to, well, how could we do this practically? And we had all sorts of crazy ideas, and that slowly led to the spiked wheel. And at every step, it sort of seemed to keep working in a way that I felt confident that I could turn it into a reliable product. One of the big challenges of any engineering development, and I've been involved in quite a few over the last 30 years, and not all of them have been successful, but the thing that's sort of behind the ones that haven't been successful has always been measurements that you weren't confident you could get a high reliability. You got too many false positives or too many false negatives. Whereas with this technology, as we evolved and came up with clever ideas, we always seemed to get back into that zone where we had confidence we could make it work.
And I think there's one, maybe something you didn't dwell on so much in your presentation. So the spiky applies the treatment at the same time as detecting, doesn't it? Sort of in the same pass over the paddock.
That's correct. It does.
Yes. Okay. Yeah. And here we go. Is the Green Party likely to support the project, do you think, or is that likely to conflict with a sort of maybe a general dislike of agriculture?
That's a very interesting one. Dairy farming is getting a lot of flack, and yet other forms of farming, including trees, are quite possibly environmentally pretty questionable compared to dairy farming. Certainly, if we can get the leaching right down, which it looks like we can, then the chances are a pine forest leaches as much as a dairy farm. It's just hard to convince people of that, and it will take a lot more of science and people to believe the science, which is kind of trendy not to in many ways. So I really don't know the answer to that, but I do know that the current government has been quite proactive and quite supportive, so there's good potential there. Yeah, I do personally find it very frustrating coming from a farming background, the amount of knocking that farming seems to get. Yet it's an important industry. It creates an awful lot of wealth in the country, and it certainly doesn't pay many people at the minimum wage, which I think is really important if we're going to have the sort of country that I want my children to grow up in. So it's very good from that perspective. That the challenge is just to address the few issues that there are and solve them, and I think technology can do that. I certainly think Spiky addresses this issue in a very good way.
Yeah, definitely. Now, how frequently would you run over a paddock with Spiky?
So it's follow the cows, and the cows rotate around the farm. So typically a paddock will get grazed 8-9 times a year. So if you're in Canterbury peak summer, you may well be grazing, rotating through every 15 days. Midwinter, you might be doing it every 90 days. But over the year, you'd use Spiky. Typically, each paddock would get done 8 or 9 times, depending on where you're farming and what your policies are.
Mm-hmm. So it's possibly more something that maybe contractors would provide as a service rather than farmers buying the gear themselves.
We certainly see the market as both. Some farmers will do it themselves. Some farmers are big enough. The Spiky that you've got in that photo there is enough for about 2,000 cows on a flat farm. So that's a pretty big farm, but then a lot of the Canterbury farms are that size. Other places, that specific unit is actually owned by 5 farmers who've effectively set up a contractor. So they bought the tractor, they bought the Spiky, and they pay the driver. And we're talking to a number of contractors at the moment in the hope that that will be a model that a lot of people use. One of the neat things about Spiky is it's an all year round operation. So from a contractor's perspective, you can get very good utilisation of his assets, which many of them like, because obviously a lot of the jobs they do, you only cut hay for a few months, few weeks a year, really, silage or whatever.
Hmm.
We're also hoping to use robots in the application as well at some point in time, but they'll be much
smaller. Mm-hmm. And have you looked into international opportunities for
I was in Ireland quite recently, and also in Switzerland, talking to some large companies there. There's a lot of interest around the world. Anywhere where the animals are spending time on the paddock. It's interesting to note that Avion bought all the dairy farms in their catchment, that's the water. Similarly, Nestle, who own Perrier, bought all the dairy farms in their catchment just to keep nitrate leaching out. So even in Europe, where they're housing the cows over the winter months, they're out on the paddock all summer, and nitrate leaching is a big issue. So there's a big market there. There's a big market in South America, Australia, certainly in New Zealand. So there is a big global market for it, and we're certainly interested in it. Having said that, from a business point of view, it's very important to get your product really, really reliable at home first. It's very expensive to support something over the other side of the world. So our first target is New Zealand.
I guess two questions that are probably sort of interrelated here. What sort of rate are you looking at for coverage? Like how many, I don't know, hectares per hour or some sort of measure like that? And what sort of cost is there in covering?
It all depends on how flat your land is and how easy it is to get around. Typically, Spiky travels at between 6 on rough land to 12 kilometres an hour. And off the top of my head, that's I think we can do up to about 6 hectares in an hour. So you can cover quite a bit of ground. And the application, we're putting on about 50 litres of product every hectare. So that's 10% of the product. That's by 10% of the hectare being treated as a sort of rule of thumb, depending on how they're operating their farm. So we can treat without refilling about 5 hectares. And again, a lot of it depends on how, the other engineering, the logistics engineering, if you like, of how you set Spiky up, where you refuel, how much time you're spending driving from paddock to paddock, and all that sort of stuff. Wherever you turn with this product, there's another bit of engineering or science. It's part of the game, I guess, to get on top of.
So how many do you have in the field, as it were? Well, it's literally in the field, isn't it?
As of tomorrow, we'll have 3 units. So we've had this unit in the photo there's been going for a couple of years. We have another unit that's been going for about a year, and another one's I'm literally commissioning it tomorrow, so I'll be jumping on a plane tomorrow morning, which is pretty exciting for us. There's been a bit of learning along the way, as is normal in engineering, and the product has certainly come a long way since we first got this unit out. And we've been exceptionally lucky with those first, that group consortium that bought it. They've been very understanding and really supportive. They want to see the technology succeed and have their farms farming for many generations to come. And it's really neat to see that support coming out of a small group of farmers.
Now, here, how much of the, I guess I'll be deliberately a little bit vague here, how much of the treatment would you normally apply in a pass?
So, yeah, the amounts we apply, so Spiky carries 500 litres, and that's enough for 10 hectares, I think I said 5 before. That contains, it's hard to say, but it contains a source of organic carbon, which is a it's a very natural product. And that's got about 50 kilograms of that in it. It has a bit of growth hormone in it, measuring that in grams, and it has a few other bits and pieces in it, but again, they're all in very small quantities, grams, literally. So, yeah, there's not a huge amount applied. We then put nitrogen on. And if you really want to get your nitrogen leaching down, it's really good to be in control of the nitrogen you put on. For example, if you have legumes, clover, or in fact gorse, which is a hybrid and produces a lot of nitrogen, you're out of control of when it's put on relative to when it's used. But if you really want to get it down, your leaching down to low levels, then you need to be able to accurately spread urea at around the 10 to 20 kilograms per hectare. And that was one of the challenges we had, because equipment to do that with emphasis on precise or accurate just didn't exist. So rather naively, and I should have known better, we decided to add that to Spiky as a sort of an afterthought, and it's become a major challenge in the development process as well. But I do think we've cracked it now, and we're getting some pretty good results out of it, so that's quite exciting.
And I think you might have covered this. What's the expected reduction in units, or however it is that you measure your nitrate?
Percentage reduction in nitrate leaching is the easiest way to look at it. So the results I have that I think would be worst case in many ways are what we had last winter. They're worst case for several reasons. One, we learned quite a lot along the way and we made some mistakes, so we can do a lot better. They're also worst case in that it rained so much last winter that a lot of the nitrate, as it formed, got washed below the grass before it could use it. I remember we had an extraordinarily wet winter. It's hard to remember after all the lovely sunshine we've had. Lovely if you're anything but a farmer, of course. But in that last year, we measured 30% reductions in Canterbury, and in a central North Island soil we were using, we measured about 25% reduction. So I guess that's the worst case of improvements that we think we can make. At times we've measured massively more than that, and we're obviously spending huge amounts of money on science right at the moment. I think it's quite realistic to assume that we'll get up to 50% reductions at least, if not higher, particularly once you start looking at the combined effect. And we're very hopeful that we will get some funding that we spent most of the lockdown writing applications for, to enable us to actually measure that on farm and real farms with systems in place so we can measure the total leaching of those properties over the coming seasons.
Oh, very good. I don't know if you'll be able to pull them up now, Jeff, but just in case you can, do you have any before and after photos of pasture?
Pull them up now.
Yeah.
But certainly you can. One of the cool things about spiky is you can actually see that it works. The farmers get grumpy when their spiky's broken down because they know they're not growing that extra grass. My background's actually in engine development, and if you give a car 10% more horsepower, very few people will notice the difference. Whereas if you grow 100% more grass on 10% of the paddock, then that patch looks a lot bigger. And so we know that just by looking at the paddock, you can see the extra grass growth, which is quite neat, and it does mean you can take those sort of photos. And I do have some, but they take a bit of hunting out to find.
I'm just waiting on another couple of questions here. Just point out it's quite interesting when you said go back to the drawing board. I'm just looking at your backdrop behind you there. You literally did at some point, I guess. An interesting blast from the past there. Haven't seen a drawing board quite like that for about 20 years.
I should confess I chose to use this office because I was hoping people would notice that. But actually my wife's an architect and she still likes to be able to draw those lovely big drawings on large pieces of paper. Where we use SolidWorks like engineering design packages. But I'm pleased you noticed.
All right, we've got another question here for you. So milking cows will excrete in the urine about 70% of the nitrogen consumed. The risk of nitrogen leaching from urine patches is much higher in winter. Do you think running a spiky in winter can damage the soil?
Not on some farms it certainly can. If your soil is really, really soft and puggy, then the tractor itself can damage the soil, certainly. But on most high leaching soils, no, you won't damage the soils. So yeah, there are some situations on some farms where it's not perfect. I heard the comment there about 70% of the nitrogen consumed. It's very variable on how much nitrogen is consumed. We all know if we eat asparagus that there's a lot of nitrogen in our urine. If we don't, then there's not. So it's the same with cows. If you're giving them a lot of nitrogen in their diet, they will excrete most of it. If you're giving them a lot less, they will excrete a lot less. And of course, that's why we want to be able to control the amount we're putting on and the amount that's actually in the leaf of the grass when it's consumed as well. But yes, there are always going to be some places where the ground is just too soft, coming back to that question. But not Canterbury. Most of the Waikato, funnily enough, is okay. Certainly around Rotorua on those sandy soils there. I mean, there's such a high infiltration rate that spiky, you won't even see where it's been even in winter, except for the tractor marks, of course.
Yeah, and I suppose in a very soft soil, a tractor would have to be set up for that anyway, with dual tyres and the like.
Certainly.
All right. Now, given your company name there, Pastoral Robotics, do you have any other robotic products on the go?
No, our plan was and remains to develop a robot that can tow spiky around. And in fact, we even have a prototype. The problem is that the difference between a prototype that works and a product you can sell is about 95% of your budget. And there's so much development going on in that space, we're very hopeful that somebody else will develop the robot and we'll supply what's called the end effector. If you look at robotics and you think about what should we automate in agriculture or use of the land, spiky is a unique application because for automation to work, and I spent a large chunk of my life in automation, you need several things. You need very good utilization of the technology, i.e. you need to be able to use that technology all year, because if you think of wouldn't it be neat if we could pick fruit automatically, and it would, and there's a lot of good research going on in that space, but the reality is you've got to recover your capital investment in 1 or 2 months of the year, whereas if you've got something that you can use all year, it gives you a much better economic picture. And spiky is an all-year application. Similarly, if you're using robotics, there's a whole lot of the simpler the application is, the more likely it will make it to market. So if you're just following a GPS trace, which is exactly what spiky does when the poor driver's driving it, he literally follows a GPS trace on a screen in front of him. The technology's already out there. There's not a lot of science required to make this product succeed. So if you like, we focused on the science. We've got that bit, the end effector, working. And really now it's a matter of finding out what's out there. And I do keep a watching brief on it, finding a suitable robot and adding the two together, and bingo, we have a robotic solution. So hopefully within a few years, we'll be able to offer something along those lines. Certainly why we chose the name. We thought we'd go the robotic route first.
Yeah, no, fair enough. Just wait till Tesla bring out the super truck. Just put some knobblies on that. There you go.
Yeah, well, wouldn't that be cool?
Another sort of slightly government-related question here. Has ECAN accepted what spiky can do in relation to nitrogen loss, and does that mean Overseer will factor in nitrogen loss reduction from spiky?
So to get to the regulatory level, we need a huge amount of research, and that's what all those lysimeters are all about. We want to get into Overseer. We have a very comprehensive plan to get into Overseer that includes a lot of those lysimeters that I showed before, plus a lot of on-farm suction cups to try and get larger scale measurements. And we need all of that science to be really well documented. And we do have an industrial partner we're working with. We've made a very big several applications to MPI that are being considered at the moment. And so, obviously we've done a lot of science. We believe we'll get there, but we really need a lot more science and a lot more independent science. So, i.e. stuff that's not done by us, but done more by Ag Research and Massey University and Plant and Food and Land Care and those sort of people. So, that's the very expensive end, and it's really what we're working on make happen right now. And I can't talk for MPI, but I'm really hopeful they will come and realise that by supporting this, we can make a real difference, both to nitrate leaching and to greenhouse gases, which is pretty exciting. So yeah. Hopefully they'll see the light.
Yeah, definitely. Now, just a supplementary question there. Can you explain what Overseer is?
Oh, Overseer, sorry. In New Zealand, we take a bit of an enlightened approach to how farmers should reduce their nitrate leaching. For example, if you've got a farm on a clay pan, well, clay is pretty good seal, so you're not actually going to leach anything. So it really doesn't matter how much nitrate you put on, because it's not going to escape out of your farm system. and into the environment. So, but if you're on a sandy soil, then it could very easily escape. So what we have is a model, a computer model with all its negatives and positives, that says, well, these are your inputs, this is your soil type, this is our best science knowledge at this point in time. We estimate your losses are X, and then the goal of the regulatory system around that is to set limits on what each farm is allowed to lose per hectare into the environment. The problem, of course, is that science is a huge moving feast, and we've learned a lot along the way. We've even learned things that put into question a number of assumptions that are in models and so forth. So we need an awful lot of science so that it's up to a regulatory standard so that we can actually stand up in court and say, well, this is what happens. And that's sort of the big challenge facing our company right at the moment, is really making that science happen, to get overseer to give it the data so that they can upgrade the model so that it's accurate in our application.
Mm-hmm. Now, another one here. There are harvesters which already have automated operation by following GPS paths. Have you looked into retrofitting existing tractors?
So the challenge with something really big like a tractor, driving with something like Spiky on behind, without a driver sitting in the driver's seat, are pretty major, and they're all safety aligned. You can't keep children, people you don't know, off the paddock on farm. I mean, most farmers live on the farm and they have children. So the moment you start letting a tractor drive on a typical rolling dairy farm, not a flat, big plains in the US, without a driver at the driver's seat, and almost all of those tractors do have drivers, although not all of them, you start to need to spend a huge amount of money on the safety systems. We haven't done it, but I would be very surprised if for this application you could make it economic. Whereas if you go to a much smaller robot that's got 24 hours in the day and drives a bit slower, so your investment up front is much less, so you can afford to cover this pasture with it, then it will stack up. And because it's much smaller, it can stop within its bumper travel and all those good things. The level of safety systems you need are much less. And again, economically, it starts to stack up very nicely. So I guess the answer is yes, the technology behind them, some of it, but not all of it is necessary if you look at the other end of the spectrum, and then economics start to look really, really, very, very positive, but not on that large scale.
Mm. I just thought of something just then that possibly our friends at Omeo might be interested in something like that, because they're probably going to get a bit less business out of the airports in the near future, so they might need to diversify.
And certainly they would have some pretty, they'd be very, all their electronics that go with controlling motors and following GPS paths and everything, they'll have all developed, and it'd be great. Should talk to them. It's as simple as that.
All right, we'll just we'll maybe do one more here. There's just one more question coming in. No pressure.
Yeah.
Well, it said someone was typing anyway. I'm still not quite sure how this works. Sometimes maybe the typing doesn't always translate. Sure.
ECAN and most of the other environment regional authorities are actually following what we're doing quite closely. We meet with them quite regularly, about to present a report to most of them, although they've probably forgotten that it's coming, about what happened over last winter and our measurements and all our data. They're certainly really, really interested in this. In fact, I see they're looking back at the notes that Bala Titsky from Waikato Regional Council placed one of the questions. We're certainly getting a lot of interest, because the poor guys in the regional authorities, they really are between a rock and a hard place. On the one count, they've got people wanting to clean up the rivers, and then in the other place, they've got people wanting to stay in business. And their goal is to achieve both of those. And this is one technology that really gives them the potential of achieving that. So we're certainly getting good moral support from them at this point in time, and a lot of interest.
Yeah, well, there's obviously, as you can see, Jeff, by the number of attendees tonight, there's been lots of interest. So that's all been very, very interesting, and thank you very much for your presentation. Yeah, I guess we'll sort of wrap it up at that. And yep. So thanks, Jeff. And to anyone that had maybe sound or visual issues or wasn't able to attend, we'll be sending the presentation out as a link to anyone that registered. And yeah, we'd normally be handing out MEG application forms at the door and press ganging you. So I'll just have to make do with a verbal reminder to join the MEG if you haven't already. It's well worth it. Oh, there's a link there. Thanks, Rebecca. Yep, there you go. There's no excuse now. All right. Well, so thank you, everyone, and we'll look forward to hearing or seeing you at the next one. We may well be in the no gatherings sort of scenario by the time we do our next presentation. So, yeah, we'll quite possibly be coming to you next time from Adobe Connect as well. So, yeah, thank you, everyone, and good night.
Thank you.